Okay, so we did leave off on Tuesday. We were talking about operations with whole numbers. So tonight we need to pick up from there, and we're going to deal with the next step, which is integers. Paper disappeared out of it. I'll find it. Integers actually include the whole numbers, but then they also include the negative numbers. So to deal with integers and how we do our operations with them, we need to take a step back and look at, remember on our numbers, like 4 inches, we have two parts. We have that count, and we have the name. For right now, for tonight, we're going to be focusing for the next little bit on just the count. That 4, that amount, and how we work with that. So the first thing we need to do is represent that count. Pretend that's straight. While you're at it, pretend these are evenly spaced. You guys will find in here that I am artistically very challenged. There's a reason I teach math. Whenever I draw pictures, we're going to have to do a lot of pretending, a lot of imagination. So anyway, let's say I want to represent the amount of 6. There are a couple of different ways I can represent that on a number line. One of them would be to just put a dot at 6. And while that represents that value very well, and if we had a lot of them to represent, that's probably an efficient way of doing it. If I wanted to work with it and do anything with it, it doesn't really help us do any of our operations. So we're not going to use that for right now to represent the number 6. Another way to represent the number 6 is with something called a vector. And a vector is just a very fancy word for a simple concept. All it is an arrow that starts at 0 and goes to the value we're trying to represent. So the vector for 6 is just that. Starts at 0 and goes to 6. Since we're talking about integers as well tonight, let's look at the vector for negative 6. That one starts at 0 and goes to negative 6. If we look at those two vectors, if I had drawn this to scale, they should be the same length, just going in opposite directions. That length, you don't necessarily need to know this word, but you'll hear me referring to it a lot, so you need to know what it means. The length is referred to as the magnitude. These two vectors for 6 and negative 6 have the same magnitude, they just go in different directions. So now let's look at how I would use these vectors for adding numbers. The operation of addition is actually defined to be combining vectors. So if I ask you to do 6 plus 4, well, I have the vector for 6 up there. The vector for 4 is going to look something like this. So addition is telling us to combine those. So I'm going to just trace that vector for 4 so I can move it here. I combine them by taking that vector for 4 and putting it at the end of the vector for 6. And you can see it ends up at 10. Well, we all knew 6 plus 4 is 10, right? We didn't need the vectors to do that. But that is our definition, the vector definition of adding two amounts or two counts. So now if I bring in the integers, the negatives, instead of 6 plus 4, let's say I want to do 6 plus a negative 4. So remember the vector for a negative 4 Starts at 0, goes to negative 4. It is the same magnitude as the 4, the positive 4. It just goes in the opposite direction. So if I take that vector and I combine it with 6, if I draw it to scale, I can see I end up at 2, right? 6 plus a negative 4 is 2. Well, I don't expect that you're going to draw out a number line every time you work with integers. I'm guessing you probably don't want to anyway. But I keep this picture in my mind as I'm working with negatives because it helps me keep track of what to do. For example, if I have something like 27 plus a negative 39, what I am thinking in my head is this. Here's 0. 27 goes in this direction. That's the positive direction. Negative 39, since it's negative, goes in the opposite direction. It has a larger magnitude, so it's a longer vector. So that means it goes past 0. Now this little image here, this little picture tells me two things about my answer. First of all, I ended up on the negative side of 0, so my answer is negative. The second thing it tells me is my vectors go in opposite directions, which means they work against each other. The result is the difference in their magnitudes. Well, the difference in their magnitudes, I have 39 and 27. That's a difference of 12. So the result is a negative 12. I might have negative 34 plus 19. Again, what I am thinking in my head is this. Here's 0. Negative 34 goes this way. 19, same direction or opposite direction? Opposite, it's positive. Is it longer or shorter? It's shorter, it's lower magnitude, less magnitude. So it stops short of 0. That tells me again, this one stops on the negative side of 0. So my answer is negative. The vectors go in opposite directions again. So that means they work against each other. So it's the difference in the magnitudes. So the magnitude of the negative 34 is 34. Magnitude of the 19 is 19. The difference is subtracting gives me 15. That result is a negative 15. If I have negative 21 plus a negative 53, what I am thinking in my head, here's 0, negative 21 goes this way. Negative 53, same direction or opposite direction? Same direction, they are both negative. Now it is longer, but it really doesn't matter since they're going in the same direction. What this tells me, my answer is obviously negative because I'm on the negative side of 0. Both vectors go in the same direction. So rather than working against each other, they build on each other. So that is 21 plus 53, which is 74. So that result is a negative 74. So keeping that picture in mind helps me figure out what I have to do with those numbers. I'm going to give you guys any questions at this point. I'm going to give you guys a few that I want you to do in your notes for me quick. So the first one is negative 63 plus 91. The second one is 48 plus a negative 73. Third one is going to be a negative 42 plus a negative 38. Have you tried those three in your notes quick, and we'll discuss them in just a second. Let's see how you did. Negative 63 plus 91. What does that become? What's that? 28. Perfect. We have negative 63. Positive 91 is the opposite direction and longer, so we end up on the positive side. They're opposite directions, so it's the difference, which is 28. 48 and negative 73. Negative 25. Good. Positive 48. Negative 73 is opposite direction and longer, so we're on the negative side. And the difference in lengths, because they're opposite directions, is 25. So negative 25. Negative 42 and negative 38. Negative 80. Perfect. They're both negative, so they go the same direction. So we're obviously negative. They add together because they're in the same direction. So it's negative 80. Anybody have questions on adding with their negatives? Okay. Where the confusion generally starts is at this next step, the subtraction. Of course, 8 minus 3 is what? 5. Good. If I were to ask you, that took off at an angle. If I were to ask you to draw a vector illustration of 8 minus 3, it would most likely look something like this. Go from 0 up to 8, then from 8 back to 5, like that. Well, this little vector here is just the vector for negative 3. What we did here actually looks a lot like the picture for 8 plus a negative 3. In fact, it is the illustration for 8 plus a negative 3. These two problems, 8 minus 3 and 8 plus the negative 3, represent the exact same thing. We've discussed a little bit about subtraction's relationship to addition, that they are the same operation, just addition is going forward, subtraction is going in reverse. There are actually some textbooks out there that would tell you that subtraction isn't even an operation, that it's just a byproduct of addition. I think that's a little harsh. Subtraction is an operation, but it is defined in terms of addition. One definition is actually 8 minus 3 is asking what number plus 3 gives you 8. So it's part of addition. It's addition going in reverse. Another definition of subtraction, a little more technical definition that I think makes more sense, is this, that symbol subtraction. By the way, any operation operates on the number that comes after it. So this subtraction here is actually operating on the 3. The first number here, the 8, is just a starting point. The operation then uses the number that comes after it to perform an operation. So that right there, that minus 3, the subtraction means add the opposite. And that's exactly what we did over here. We added the opposite of 3 was a negative 3. Now in a problem like this, 8 minus 3, we know how to subtract that. So I wouldn't change it to adding a negative, because we know how to subtract 8 minus 3, we just as well do it. But there are problems that are not as obvious as that. For example, we might have negative 24 minus 17. That one, you can't just look at it and know the answer to it. It's simpler to figure out what the answer is if I change it to addition. The negative 24, remember, that first number is our starting point. So that is going to stay negative 24. That will never change. What changes is the operation, the subtraction, and the number that comes after it. So that subtraction becomes plus, what's the opposite of 17? Negative 17. So negative 24 minus 17 is equivalent to negative 24 plus negative 17. And now that it's like that, we can do our picture. Negative 24 goes this way, negative 17 goes the same direction. So we end up in the negative side of 0. The vectors go the same direction, so we're combining them. 24 and 17 make 41. Does that make sense? Any questions? So if I have negative 48 minus 59, what is that equivalent to? The negative 48 doesn't change. What's this become here? Subtraction becomes addition. 59 becomes negative 59. There we go. So that's negative 48, negative 59. That result would be negative 107. Perfect. It can be a little more confusing if we have something like this. 24 minus a negative 13. Now, written like that as subtraction, that makes almost no sense. It's really tough to figure out. But we're going to change it. Remember the 24, the first number never changes. This becomes plus the opposite of the 13, negative 13. What is the opposite of negative 13? Positive 13, or just 13. So 24 minus a negative 13 just becomes 24 plus 13, which is 37. Wonderful. Come on. Or we might have negative 52 minus a negative 38. What's that equivalent to? Negative 52, somebody give me the rest of it. Plus, yeah, and the opposite of negative 38 is a positive 38. So it is negative 52 plus 38. Here's 0, negative 52. Positive 38 is the opposite direction and slightly shorter. So what's my result? Negative 14. Any questions there? So have you guys try a few of them again? The first one will be negative 72 minus 53. Negative 48 minus a negative 61. And 27 minus a negative 19. Let's take a couple minutes to try those two, and then we'll talk about them in just a second. There we go. We have here, what is the result for negative 72 minus 53? Negative 125. Wonderful. Negative 48 minus a negative 61. $13. Good job. And negative 27 minus a negative 19. Sorry, positive 27 minus a negative 19. 46. Good. Anybody have questions with subtraction? I want to see more examples. Okay. Our next step, multiplication. We've already mentioned that multiplication, when we have something like 5 times 3, that the definition of that multiplication is repeated addition. It's asking us to take that 5 and repeat it 3 times. 5 plus 5 plus 5 gives us 15. So it's not much of a stretch to do negative 5 times 3 and to realize that's asking us to take negative 5 and repeat it 3 times. Negative 5 plus negative 5 plus negative 5 would be negative 15. Well, a little bit trickier is to think about 5 times a negative 3. And to work with that, we need to take a look at some properties of numbers here quick. For addition and multiplication, those two are what are considered our base operations. Subtraction, I mean, like I said, some textbooks say it's not even an operation, but at the very least, subtraction is part of or a byproduct of the addition. Same with multiplication. Multiplication is a base operation. The division is part of the multiplication. So it's not necessarily its own thing. So the addition and the multiplication are the base operations. The base operations are what we call commutative. What commutative means is quite simply, we can change the order of the two numbers that we were trying to combine. So if I had 4 plus 7, what does that give me? Not everybody at once. Be brave. What's 4 plus 7? 11. There we go. What if I switched it around and did 7 plus 4? It's still 11. Good. That's what we mean by commutative. 4 plus 7 and 7 plus 4 give me the same answer. Or what if I have 3 times 5? It's 15. 5 times 3? Also 15. Multiplication is commutative. I can switch the order of those two numbers when I'm multiplying, and I'm still going to get the same result. So when we say commutative, that's what we mean by that. Now, obviously, subtraction and division are not commutative. If we're subtracting and we switch the order of the numbers, it is going to make a drastic difference in our result. So back to this little issue right here, the 5 times negative 3. We can change that to a negative 3 times 5 because it's commutative. Now that's saying take that negative 3 and repeat it 5 times. So negative 3 plus negative 3 plus negative 3 plus negative 3 plus negative 3, which is negative 15. Right? Many of you have probably been taught at some point that if you have a negative times a positive, the answer is going to be negative. And if you have a positive times a negative, the answer is going to be negative. And you've probably even been taught this next one. Negative 5 times a negative 3. A negative times a negative has to give you a positive. So negative 5 times negative 3 would be positive 15. Well, the question is, why? Because if we look at that, if it's asking us to take negative 5 and repeat it negative 3 times, that doesn't make much sense. Even if we switch it around and do negative 3 times negative 5. Taking negative 3 and repeating it negative 5 times doesn't make much sense. Our definition of multiplication doesn't work with this problem. We run into that actually quite a bit in math, where the basic definition of an operation or of a process doesn't work on a particular problem. When that happens, what we do is we go back to places where it does work and we try to create a pattern. So I'm going to start with negative 5, and I'm going to multiply it by something that we know works, which is a 3. What is negative 5 times 3 again? Negative 15. There we go. Now what I'm going to do is I'm going to keep the negative 5. I'm going to start with that again, but I'm going to reduce what I'm multiplying by from 3 down to 2. So I reduce that by 1. What is negative 5 times 2? Negative 10. Good. I'm still starting with a negative 5. And again, I'm going to reduce what I'm multiplying by 1. So if I reduce that by 1, it should be 1, right? 2 minus 1 is 1. Negative 5 times 1 is negative 5. Let's see if I can find the pattern here. So I'm starting with negative 5 each time. I'm reducing what I'm multiplying by 1 here. What happens to my answer, my result? It increases by 5, from negative 15 up to negative 10. I reduce this by 1. This goes up by 5, right? So let's check to see if that pattern keeps going. So this stays negative 5. What is this? What do I have to multiply by here? If I subtract 1 again, it would be 0. What's negative 5 times 0? 0. Did this increase by 5 again? Yes, it did. So the pattern seems to be working. So now let's keep going. Negative 5 times. If I reduce this by 1 again, it's going to be negative 1. Good. And you have to increase this by 5. It would be 5. Negative 5 times. Reduce that by 1 to negative 2. The answer has to increase by 5 to be 10. Negative 5 times, the next step would be negative 3. This has to go up by 5 to be 15. Now I realize that's the long answer to get to the reason why negative 5 times negative 3 is a positive 15. But that process happens a lot in math, where the basic definition of an operation breaks down. Like taking something to the power of 0. There's a couple other things where that pattern, the basic definition doesn't work, so we have to rely on a pattern to tell us what it has to be. Okay, so anyway, with that said, let's summarize the multiplication. If I have negative 8 times 5, first of all, is that answer going to be positive or negative? Negative. A negative times a positive is a negative. What is 8 times 5? 40. So that has to be a negative 40. If I have a negative 7 times a negative 4, my answer has to be positive or negative? Positive. Negative times a negative is a positive. 7 times 4? 28. So negative 7 times negative 4 is a positive 28. 3 times a negative 9, is the answer positive or negative? Negative, good, because we have a positive times a negative, has to be a negative. 3 times 9 is 27, so it's negative 27. So again, just to reestablish or reaffirm what you've learned before. When we're multiplying, anytime we have one negative and one positive, no matter what order they're in, the result is going to be negative. Anytime both numbers are positive or both numbers are negative, the the result will be positive. Now that same rule applies for division. You've probably seen it and memorized it for division as well. But I want to show you a little bit about how it is developed. And to do that, I want to talk a little bit about the definition of division again. We talked a little bit about 8 minus 3 equals blank. What that is asking is that what plus 3 equals 8. So we're defining that subtraction in terms of addition. Division can be defined similarly in terms of multiplication. 24 divided by 8 equals what? What that's asking us is what number times 8 equals 24? Well, what number would I fill in the blank here? 3. 3 times 8 is 24. Therefore, 24 divided by 8 is 3. So if I have negative 30 divided by 5, what that is asking me is what number times 5 equals negative 30. Now, to get a negative result when I multiply, remember we have to be combining one positive and one negative. Well, the 5 is already positive, isn't it? So what does that tell us about this missing number? Has to be a negative. What times 5 is 30? 6. So that is a negative 6. Negative 30 divided by 5 is a negative 6. Or we might have 45 divided by a negative 5. That's asking us what number times a negative 5 equals 45. Well, to get a positive result in multiplication, either both numbers have to be positive or both negative. This one's already negative, so that means this one must also be negative. So what times 5 is 45? 9. So negative 9 times negative 5 is a positive 45. So 45 times negative 5 has to be a negative 9. And finally, we might have something like a negative 36 divided by a negative 4. And that is asking us what number times negative 4 equals a negative 36. So one more time, we're looking at the result of a multiplication is negative. For that to happen, we must be combining one positive and one negative. This number here is already negative. This one has to be positive. What times 4 is 36? 9. So it's a positive 9. So just to reaffirm what you've learned before, a negative divided by a positive is negative, or a positive divided by a negative is also negative. So again, just like with multiplication, if we're dividing two numbers where one is positive and one is negative, the result's negative. If we're dividing and both numbers are negative, the result would be positive. Now again, hopefully you guys have seen that stuff before a little bit, and it's not a horrible surprise to you. So then for the next step here, I want to look at another operation, a new operation. What does that mean? 5 squared. How would I calculate it? Five times 5, right? That's its definitions. Just like multiplication is repeated addition, a power is repeated multiplication. 5 times 5 is 25. I'm going to leave a little space here. How about 8 to the third power? The 8 cubed, or from calculate 8 times 8 times 8. Or 512. The first thing I want to do here is I want to make sure you guys know where that power key is on your calculator. Depending on your calculator, you may have one of a couple different keys. The most popular one is a key that looks like that. The name for it's actually called a Caret key. On my calculator, you can see it right there. It looks like a little arrowhead pointing up. Some of you might also have a key that looks like this, X to the Y or maybe Y to the X. Both of those keys work exactly the same. If I wanted to enter 8 to the third power, I would type in the 8, press whichever one of those keys I have, then type 3 and hit equals. It should give you 512. So for those of you with your calculators on you, I'm going to see if you can beat me here. I'll be erasing it quick. 5 to the power of 4. Does it come out to 625? Okay. How about 3 to the power of 6? 729? I'll give you guys a little bit of a chance here. 2 to the power of 12. 4096? Okay. Now, obviously, I've done these a few times before, but I've mentioned it before. You're going to hear me mention it a lot before the semester's over. Math is about patterns. All of these have patterns that they follow. And once you start to see the patterns, those calculations are relatively simple. So now back to what we were talking about here just a few minutes ago, our integers. What is negative 5 squared? Well, that's negative 5 times negative 5. What should it be? Positive 25. A negative times a negative is a positive, right? So those of you that have your calculators with, I want you to try to do that because there's actually a very common error that happens in calculators with this one. By the way, you can't use subtraction as your negative on most calculators. Most calculators have a negative button. On mine, you can see down here, it's actually the minus sign in parentheses. So I enter negative 5 and then I hit squared. My calculator tries to tell me negative 25. Anybody else's do the same thing? Okay. What is happening there is actually something called order of operations, which we're going to talk about after our break here in a little bit. What it is the power happens before a negative. So what the calculator is doing is looking at that, saying I have that 5, there's a negative sign in front of it and a squared or a power after it. The power goes first. So it's squaring 5 to get 25 and then applying the negative to it. So on most calculators, if you want to square a negative number, you have to put it in parentheses like that, negative 5 in parentheses. And then, oops, wrong key. Negative 5 in parentheses and hit x squared. And then it does give you the correct answer of 25. How about if I have, bless you, negative 7 to the power of 3? It is safest if we use parentheses, but this one, then I got to use my caret key because I don't have a third power, does come out to be a negative answer, negative 343. How about if I have, let's do 6, negative 6, the power of 4. What's that one come out? It's going to come out to be 1,296. If you think about these last two, what happened here with the negative 7 to the third power? Well, that's negative 7 times negative 7 times negative 7. When I go to combine there, negative 7 times negative 7, well, a negative times a negative is a positive. It's a positive 49. Then I multiply that by the next negative 7. A positive times a negative is a negative. 49 times 7 is 343. So that comes out to be negative. That is correct. Up here for negative 6 to the power of 4, that's negative 6 times negative 6 times negative 6 times negative 6. When we try to multiply that out, negative 6 times negative 6, negative times a negative is a positive 36. Times the next one, 36 times a negative 36. Positive times a negative is a negative. That would be 216. Take that times the last negative 6. Well, it's a negative times a negative, which would be positive again. 216 times 6 is 1296. You might see a pattern developing here. When the power was even, the result was positive. Then power was odd, it gave us the negative. So if I had negative 2 to the power of 7, would I expect that answer to be positive or negative? Negative, because of the odd power. That actually comes out to be negative 128. Okay, it is time for our break. So let's go ahead and take our break. It is 4:20 here on the computer clock, and we'll come back at 4:30.